Hello students! Welcome to our class. This is Teacher Beth. For today's lesson, our topic is about arithmetic sequence. We have two objectives that we should attain at the end of the discussion. First, we have to be able to define and illustrate an arithmetic sequence. Second, to determine arithmetic means and solve for the nth term of an arithmetic sequence. Are you ready? Let's start. What is an arithmetic sequence? Arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same. It is constant. This constant term is called the common difference, and it is denoted by the small letter d. Arithmetic sequence can be in increasing or decreasing order. Let's have some examples. We have 21, 31, 41, and 51. Getting the difference of any two consecutive terms, we have 10 as the common difference. Is it increasing or decreasing order? Increasing, very good. The terms are arranged least to greatest. Another example, we have 28, 24, 20, and 16. Getting the difference of any two consecutive terms, we have negative 4 as the common difference. Is it increasing or decreasing? That is correct, decreasing. Very good. The terms are arranged from largest value to smallest. How can you tell whether a given sequence is an arithmetic sequence or not? By the common difference, correct. Because by the definition, arithmetic sequence is a sequence in which there is a common difference. Let's have this example. We have 21, 38, 55, 72, and 89. Is it an arithmetic sequence? Let's find out by getting the difference of the consecutive terms. 38 minus 21 is equal to 17. 55 minus 38 is equal to 17. 72 minus 55 is equal to 17. 89 minus 72 is equal to 17. There is a common difference which is 17. Hence, it is an arithmetic sequence. Another example, 2, 4, 8, 16, and 32. So let's find out if it is an arithmetic sequence by getting the common difference if it has. Okay, 4 minus 2 is equal to 2. 8 minus 4 is equal to 4. 16 minus 8 is equal to 8. 32 minus 16 is equal to 16. So as you can see, there is no common difference. Therefore, it is not an arithmetic sequence. Remember, it is an arithmetic sequence only if it has a common difference. Let's try to answer this one. Write the next three terms of the sequence 7, 5, 3, 1, and negative 1. So first, we have to find the common difference by getting the difference of any two consecutive terms in the sequence. 5 minus 7 is equal to negative 2. 3 minus 5 is equal to negative 2. 1 minus 3 is equal to negative 2. Negative 1 minus 1 is equal to negative 2. So the common difference is negative 2. We have to add negative 2 to get the next three terms. We have to find the next three terms of the sequence 7, 5, 3, 1, and negative 1. So we are looking for a sub 6, a sub 7, and a sub 8. To find a sub 6 or the sixth term, we have to add a sub 5 and the common difference. So that would be negative 1 plus negative 2 is equal to negative 3. So our sixth term is negative 3. Next, a sub 7 or the 7th term is equal to a sub 6 plus d. So that would be negative 3 plus 2 is equal to negative 5. So the 7th term is negative 5. A sub 8 is equal to a sub 7 plus d. So that would be negative 5 plus negative 2 is equal to negative 7. So the next three terms of the sequence 7, 5, 3, 1, and negative 1 are negative 3, negative 5, and negative 7. Another example. Determine the next three terms of the arithmetic sequence 6, 12, 18, and 24. So first, let's solve for D, or the common difference. So 12 minus 6 is equal to 6. 18 minus 12 is equal to 6. 24 minus 18 is equal to 6. So the common difference is 6. We are tasked to get the next three terms of the sequence 6, 12, 18, and 24. So that would be the 5th, 6th, and 7th term. So a sub 5 is equal to a sub 4 plus d. So that would be 24 plus 6 is equal to 30. So our 5th term is 30. A sub 6 is equal to a sub 5 plus d. So that would be 30 plus 6 is equal to 36. So our 6th term is 36. Next, a sub 7 or the 7th term is a sub 6 plus d. So that would be 36 plus 6 is equal to 42. So our 7th term is 42. So the next three terms of the sequence 6, 12, 18, and 24 are 30, 36, and 42. In general, the arithmetic sequence a sub 1, a sub 2, a sub 3, a sub 4, and a sub n with the common difference d can be written as a sub 1, a sub 1 plus d, a sub 1 plus 2d, a sub 1 plus 3d, a sub 1 plus n minus 1 multiplied by d. Hence, to get the nth term of an arithmetic sequence, we can use the general form of an arithmetic sequence, which is a sub n is equal to a sub 1 plus n minus 1 multiplied by d, where a sub n is the nth term or the last term, a sub 1 is the first term, n is the number of terms in the sequence, and d is the common difference. Let's have some examples. Find the 12th term of the arithmetic sequence 3, 5, 7, and 9. To solve for this, we have first to identify the given. A sub 1 or the first term is 3. Our n is 12 since we are looking for the 12th term, and d, so we can solve for the common difference, and that is 2. Substituting in the formula, a sub n is equal to a sub 1 plus n minus 1 multiplied by d, we have a sub 12 is equal to 3 plus 12 minus 1 times 2. A sub 12 is equal to 3 plus 11 multiplied by 2. So a sub 12 is equal to 3 plus 22. So a sub 12 is equal to 25. So the 12th term on the arithmetic sequence 3, 5, 7, and 9 is 25. Another example. Find a sub 10 or the 10th term of the arithmetic sequence negative 3, negative 6, negative 9, and negative 12. To solve, let's list down our given. Our first term is negative 3. our n, or the number of terms, is equal to 10 because we are looking for the 10th term. Our common difference, so by getting the difference of any two consecutive number in the sequence, so our d is equal to negative 3. Substituting in our formula, a sub n is equal to a sub 1 plus n minus 1 multiplied by d. So a sub n would be a sub 10. A sub 1 is equal to negative 3. N is 10 minus 1 and d is negative 3. So a sub 10 is equal to negative 3 plus 9 multiplied by negative 3. So 9 multiplied by negative 3 is equal to negative 27 plus negative 3. So a sub 10 is equal to negative 30. So the 10th term of the sequence negative 3, negative 6, negative 9, negative 12 is negative 30. Take a look at this problem. Find the 7th term of an arithmetic sequence if the 3rd term is 5 and the 5th term is 11. As you can see, the first term, or a sub 1, is unknown, as well as the common difference. So how are we going to solve for the nth term if the first term and the common difference is unknown? So plotting our sequence, we have a sub 1, unknown, a sub 2, unknown, a sub 3, 5, a sub 4, unknown, and a sub 5 is 11. So 5, a sub 4, and 11 have a common difference. So we can use the formula a sub n is equal to a sub 1 plus n minus 1 multiplied by d to get the common difference. A sub n would be the last term. So the last term is 11. A sub 1 would be the first term, and that is 5. And n would be 3. So substituting in the formula, a sub n is equal to a sub 1 plus n minus 1 times d. So 11 is equal to 5 plus 3 minus 1 times d. So 3 minus 1 is equal to 2 multiplied by d. So that would be 2d. So 11 is equal to 5 plus 2d. Applying APE, so 11 minus 5 is equal to 2d. So divide both aside by 2 to get d. So d is equal to 6 divided by 2 is equal to 3. So our common difference is 3. So we can add this common difference to our last term to get the 7th term. So a sub 6 is equal to a sub 5 plus d. So that would be 11 plus 3. So is equal to 14. Our 6th term is 14. We are looking for the 7th term. So for the 7th term, we have a sub 7 is equal to a sub 6, or the 6th term, plus d. So that would be 14 plus 3 is equal to 17. So the 7th term of the sequence is 17. Another example. If the 3rd term of an arithmetic sequence is 13 and the 9th term is 37, what is the common difference? So now we are looking for the common difference. So plotting the sequence, we have 13 as a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, a sub 8, unknown, and a sub 9, or the 9th term is 37. So we are looking for the common difference. So listing our given, 13 would be our first term, or a sub 1, n would be 7 because we have 7 terms from a sub 3 to a sub 9, and a sub 7, our a sub n, or the last term, is 37. So substituting in the formula, we have 37 is equal to 13 plus 7 minus 1 times d. So 37 is equal to 13 plus 6 multiplied by d. So 37 is equal to 13 plus 6d. So, applying APE, 37 minus 13 is equal to 6D. So, solving for D, divide both sides by 6. So, D is equal to 24 divided by 6. And that would be 4. So, the common difference is 4. Okay, next, arithmetic means. So what is an arithmetic mean? Arithmetic mean is a term between two given terms. In the arithmetic sequence 5, 8, 11, 14, and 17, there are three arithmetic means between 5 and 17. These are 8, 11, and 14. So let's have an example. Insert three arithmetic means between 17 and 1. So let's list down our given. A sub 1 or the first term is 17. Our n or the number of terms is 5. Our a sub 5 or the last term is 1. And d or the common difference is unknown. Substituting in the formula, so a sub 5 or the last term is equal to a sub 1 plus n minus 1 times d. So 1 is equal to 17 plus 5 minus 1 times d. So 1 is equal to 17 plus 4 times d. So 1 is equal to 17 plus 4d. So applying APE, 1 minus 17 is equal to 4d. So that would be negative 16 is equal to 4d. Solving for d, so divide both sides by 4. So d is equal to negative 16 divided by 4. So that would be negative 4. So our common difference is negative 4. So we have to add negative 4 to the terms to get the arithmetic means. So that would be our first term, 17 plus negative 4 is equal to 13. So that is our second term. Next, 13 plus negative 4 is equal to 9. So that is our third term. Next, 9 plus negative 4 is equal to 5. And that is our fourth term. So checking, 5 plus negative 4 would be 1. And that is our fifth term. So the arithmetic means between 17 and 1 are 13, 9, and 5. Another example. What is the arithmetic mean between 85 and 95? So listing our given, a sub 1 or the first term is 85. Our n or number of terms is 3. A sub 3 or the last term is 95. And d or the common difference is unknown. So substituting the given to the formula to get the common difference, so a sub 3 is equal to a sub 1 plus n minus 1 times d. So 95 is equal to 85 plus 3 minus 1 times d. 95 is equal to 85 plus 2 times d. So 95 is equal to 85 plus 2d. So 95 minus 85 is equal to 2d. Dividing both sides by 2 to get the d. So 10 divided by 2 is 5. So the common difference is 5. To get the arithmetic mean, we have to add the common difference. So that would be 85 plus 5 is equal to 90. So the arithmetic mean between 85 and 95 is 90. So let's have a recap on our discussion. What is an arithmetic sequence? Arithmetic sequence is a sequence with a common difference on any consecutive numbers. So the general form of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. And that is the end of our discussion for today. I hope you've learned a lot. Till our next discussion, stay safe everyone!